Hey, directed study, back at it again. Howdy, howdy for our first actual week of the e-learning here. If noises go on and off a little bit here, if you didn't check out my other video that I sent out here, that'd be sometime last week. Down here in my big fancy office basement, we're dealing at times with the furnace, all sorts of other interesting things. No 5-year-old running through yet. Hopefully not during this lesson, we'll see. But all right, here is our first assignment here. We're going to do a couple of these a week. You can keep up to these on the website. So this week we're going to do a little bit of review again with the Pythagorean Theorem because it's going to roll into something a lot of you are going to be seeing here in the next week or so if you haven't, which is dealing with chords of circles. We'll tackle that a little bit here too in a simpler form for you. So let's take a peek. Find the missing side of the triangle, leave your answers in simplest radical form. Remember, a squared plus b squared equals c squared. And c squared is always the hypotenuse, the side across from the right triangle. So let me give you a hint here right off the bat. I would always find my right angle first in each of these, and immediately label my hypotenuse. The two legs, it really doesn't matter what order they're in, but making sure the hypotenuse is somewhere that we belong is very important. So we're going to want to make sure that we do that. So, for instance, on number 1 here then, and again, teachers do this different ways. I'll show it both. I notice here my hypotenuse is what I'm looking for. So what I'm going to do here is I'm going to do a squared plus b squared, I'll explain my parentheses in a second here, equals c squared, equals my hypotenuse squared. And so I'd sent out a link, okay, late last week again to all of you through the Skyward and through the email of a way that you can get the TI graphing calculator, like I have the nicer ones here that I have normally in my classroom here. You can have this on your netbook if that is something that is helpful to you, or also one of the other apps we've talked about for the phone. Now, we're really not going to need anything fancy for this. Just a basic scientific calculator would help. And so what I'm going to do, once I get it turned back on here, try and get it where you're not seeing it through my big noggin, is getting through here. I do not have to have I got to make sure the squared, though, isn't inside where it was before. If some of you noticed when I was in here before and typing, if I'd have kept typing and typed the squared would have been underneath the radical button here, and I wouldn't have wanted that. That would have gotten me a whole different answer. So we just want to make sure that it's outside. And so once I get that, okay, that's not my answer because that's what x squared is. So I'd still have to do the square root of that. And if you're using the fancy schmancy calculator that got downloaded, square root is second and the x squared button. It's about halfway down on the left there. And so we get that in there, 114. And I notice I get a decimal. You're like, oh no, not this again. Hardy, can I just put the decimal? I'd rather have you do that than nothing, but again, if we're learning how to follow directions here, leave your answers in simplest radical form. What I would typically do here, since I got 114 and I got a radical, would be to try some of my small perfect squares. You're like, now what are those again? Glad you asked. And normally I'm not going to go up real high, so I'm not going to go crazy with this. I think I'm going to stop at 64 here. Those are my perfect squares. So those are the ones that I'm going to take a real quick attempt. Notice how quickly I can do this. It's not taking me a real long time on this. Okay, and I'm finding out that none of these are going to go in. So my answer in this case is just leaving it as the radical. And that's how you'll see it on the answer key that I post. Let's talk about that while we're here. When I post the answer key, it's just going to be answers. Okay? If I get assignments turned in from you, and we'll chat a little bit about that too here at the end on this first one, you're not going to get much of credit because all I'm basically going to assume you did was look at mine, do that, or go find an app, wrote the answer, get it. I want to see this. If you show me that stuff, I'll give you credit. Okay? We can raise your grade up while we're out here. It's a win-win situation. Okay? Just something for us to consider. Now, one other thing I will mention. Boy, am I in a nice mood today? I am in a nice mood today. I'm going to do number 2 here. I wasn't going to do number 2. I was just going to do number 4 next. But I'm going to help out here. Just because we can get caught into a problem otherwise with these. I look at number 2 and I go, ooh, I have the hypotenuse this time. So it's always the sum of the squares of the sides first. X squared plus square root of 11 squared equals 2 square root of 3 squared. Because it always equals hypotenuse squared. So once I do that, a couple of things to notice. If you don't remember this from before, if I take the square root of 11 and square it, I get 11. Okay? So anytime, oops, let me move that where you'd actually, again, be able to see it through my head. If you just have a square root with a square, it's just going to cancel it out, but ooh, be careful here. Oh dear, what's going on here? Well, let's type it in the calculator and then see where it came from. So 2 times the square root of 3 squared. Okay, we got 12. Now, let me show you where 12 came from here. 12 came from that squared going to both the 2 and the 3 here. 2 squared is 4. And we just got done saying if you square with a radical, it just cancels it out and makes it 4 times 3. That's where the 12's coming from, just in case you're wondering. And now we just solve it. Minus my 11 over. Other cool thing about watching me on video instead is you can pause me when you want to. You can go get a snack. You can rewind me if you missed something. It's all good. And the square root of 1, last I checked, is 1. So some of these answers are going to come out nice. Okay? But it's a nice way for us to be able to see what's going on with these. Finally, there's one more I wanted to do. Okay, number 4. Doesn't look like it's too bad. There's no radicals even in it. Let me get my hypotenuse label. So I'm like, okay. And yes, I know some of you are hollering at me through the screen right now. When you have the hypotenuse, can't you just do hypotenuse squared minus legs squared? You can. Nicely done. Some of you might be wondering why I'm never looking at the screen. I'm trying to look at the screen. Hi. But I kind of run into my microphone here, and I also want to be writing off to the side here, so it's kind of tricky. So x squared plus 7 squared, my 2 legs, doesn't matter which order you put them in, equals my hypotenuse squared. And I would go into my calculator, type in my 7 squared, type in my 15 squared, and now we're into a situation that's really similar to what we were doing in number 2. I want to get x squared alone. We're going to minus the 49 over. And I go to my handy dandy calculator here, trying to keep everything in the screen besides my head. Square root of 176. And some of you are like, well, this is just like number 1. Why'd you do this one? Thanks for doing it, but why'd you do it? This one, there might be a little more to this. So let's try some of our perfect squares this time and see if we can find one. And some of you will be like, why are you starting with the big ones? Why didn't you just start with 4? Well, let me show you here in a minute why I didn't start with 4. You're like, are any of them going to work? Anybody? Anybody? Now, just show you something. You're like, well, 4 worked too. So can I do either? Yes and no. Okay, we always want to get the biggest one. Because if I get the 16, okay, if I do 16 and 11, color change coming up here. Okay, if I do 16 and 11, the perfect square gets out of radical jail. We've talked about this before. So my answer, my best answer, is 4 square root of 11. Well, what if I'd have done the 44 instead? I'd have still gotten an answer with a radical. It would have been 2 radical 44, but I could have broken the 44 down again. I don't want to have to do that if I don't have to, okay? So that's just our thing. Now, if you put that, I'm still going to give you credit because that's still a good job of recognizing that. But show work, do the best you can. Check answers. I'm going to have an answer key up posted on the site too, probably right below where this video is, so you can kind of see what's going on with that too. And you can always shoot me questions. I check my email a lot. May have to pop an extra video up, and that'd be okay if we had to do that. Okay, then to the back. Don't freak out, some of you that have not seen a bunch of this yet. We're going to simplify this way down. And here's what it looks like. Find the length of the segment indicated using the Pythagorean Theorem. Okay, we just got done with that. That's not bad. Reminder, if a diameter or radius is perpendicular, forms a right angle, to a chord. You're like, okay, for some of you that are just starting, what's a chord? A chord, let me move this down a little so we can draw a little picture. A chord is going to be any line that just basically connects on two sides of my circle. Okay? Doesn't have to go through the middle like a diameter, but if it connects on two of the edges, it's a chord. So they can be all sorts of different sizes and shapes. All three of those lines I made there would be examples of chords. So this would be like having three different chords, but you're not going to have that to worry about. Some of the problems down here are going to be really straightforward. Some of them aren't going to be. Okay? I'm going to deal with a non-straightforward one for you here right off the bat. You're like, okay, I'm trying to find x. Okay, I know this side is 6.4. That's my hypotenuse. Hardy, I don't know what this is. But you do. You're like, I do? You do. This is a chord, okay? Begins and ends on this line. Now, if it's perpendicular, it is. There's my little right angle guy. It bisects, okay? It cuts it in half. They're congruent, the two pieces. So if this piece of my chord is 10.3, this piece of my chord, finally the furnace went off, this is 10.3. And so now if I'm looking at this triangle where my missing piece is, I've got the two legs, I'm just looking for the hypotenuse now. It's just like the front was. So I'm going to do 6.4 squared plus 10.3 squared equals x squared, because I'm looking for my hypotenuse. So we're going to go ahead. We're going to get this into the calculator. Okay, we get a big old decimal. We're going to take the square root of it. Again, second and x squared if you are using anything like this. And this time, no, we are not doing radicals. Okay, what's it say? Round to the nearest tenth, so to 1 decimal place. So 12.1. Okay, there may be a little extra work. We had to situate a couple of things here, but that's okay. Okay. Now, sometimes we may not have to do that. Sometimes we may get lucky, like with number 7. Everything I need is here. So I'm looking across here as I go. It's crazy how life happens as you're doing these. I'm like, I need quiet and people are texting. Oh, gracious. Well, life, this is why we don't do school stuff at normal, because people just don't understand. All right. Oh, man. Ugh. So here, hypotenuse, there's my two legs. Legs squared plus legs squared equals hypotenuse squared. For your enjoyment here, I am not going to make you stare at the calculator for all the pieces of this. I'm just going to square these out for you. But this time, however, I can't take the square root right away. Why? Well, because the x squared is not on a side by itself. So we're going to subtract that over. Grab my calc here for a sec. 20.32, and we'll take the square root of that. So the square root of that would get me about 4.5. Okay, now that's the last one I'm going to do in full. I am going to give you one more hint on one question, just in case you're wondering. Okay, sometimes we take stuff we've learned and we completely forget we've learned it because we get so locked in on something. I'm talking about chords, I'm talking about the Pythagorean Theorem, and then you get to a problem like number 9, and some of you may panic a little bit because you're like, okay, well that's a chord, well then that's x. And I'm like, yeah. And people are like, but I'm still missing, I need to find, and you're like looking at it and you're like, oh, wait a minute. Oh, I have all the pieces. Right. Okay. Take your time on this stuff. Or maybe even you get down to the bottom with number 11 here. And again, you're looking, you're going, okay, well, that's a, oh, and I've got all the pieces. Okay, you got this. You really do. Now, let me mention again, if you haven't, and you need to go watch those other messages I've sent to you if you haven't, how do I send this to Hardy when I'm done? Okay. I know from my own experiences, y'all got some weapons of mass distraction out there. You got your phones. That's going to be your easiest way to do this. So when you get done, you're going to bust out your phone. You probably are like, Hardy, you really don't think we know how to do this already? I don't take anything for granted anymore. And what you're going to do is you're going to grab out your handy dandy phone. You're going to do your best to get the whole page in there. Try to get the work and all that stuff in there. You're going to take you some pictures. And then what you're going to do is you're going to email me, okay, back as an attachment, your assignment. And this way I can go back and forth with you. Now, reminder again, you keep getting all these emails from me, though. You really shouldn't need to get me again here, but I'm going to say it just in case. Okay. And I'll be honest, if I don't see things from some of you, I'm probably going to start emailing you and going, hey, hi, how you doing? What's up? Where's your stuff? Because again, this is a great opportunity for some of you. If your grades have been a little like, do these quick, and I'm just going to put them in as positive scores, and off they go. Okay? I can even give you the points for, class participation that some of you have issues with sometimes. I can't sit there and stare at you through my webcam here and go like, what are they doing over there? Are they doing the goofy stuff? I can't do that. So if you're doing it, you're going to get points for those too. And it's a real easy way to boost your grades up. So I'll be doing this a couple of times a week. If you are having some issues in your regular geometry class with stuff, take a picture of it, shoot me an email, or just say in general what some problems are. Maybe I can find a topic helper for you, a different video online. Shoot, if I can hear some of you asking for the same thing, I might jump on here and create something myself. But I am keeping an eye on your geometry teachers' pages too during this, trying to get a feel for what they're doing too, so I can be as relevant to what's going on there as I can. So if there's things I can help out with, let me know. Do not send me a copy of your current quiz if you have quizzes with your classes and tell me to help you with those. You'd be better than that. So hope you're staying safe and sane, and I'll be checking back with you soon. See you. Peace.